Oh, because it's the first time through it's empty. The first time through it's empty because of... But don't I want to write it down? I think if the objects is empty, I don't want to do this. Huh. Okay, so did I save everything? So if I write you, we get to see, okay, here's tree 336, and then we get to see all the stuff, right? No, okay, so we only get to see this once. That's fine. So you'd like to use Git to store the 3 files you have, write a Git plumbing tool to dump segments of a Git repo, compare what is generated by real Git versus Brooks Git. Yeah, that might be a good idea. Run the dumper on 2 repositories, one known to be right, one under development. Oh, that could be interesting. I can't help but wonder. Okay, so this is running. I guess the other thing is I probably want to get rid of all these warnings just to make less stuff showing up in the terminals. Let's get rid of warnings now. Okay, so we got no more warnings. We should be good to go. Let's try running this again. There we go. Okay, so this first time it writes, I wonder if that's causing a problem. That being said, I'm not running this multiple times, am I? Why am I getting this written twice? Okay, so line 49 is writing... Okay, so we're getting this tree file back. And then I'm writing save the disk on the tree file. And then we're returning the hash, but obviously that's only going to work if there is something, if there are objects to push in. Why do you have warnings? Just program well from the start. I mean, you're not wrong. I used to work with an instructor that whenever, like, students, when they were like, why does my code not work? And, his response was just to shrug and say, well, I mean, just code better. So yeah, I just need to code better. We need to get good. Are you running file and append? You should effectively, yeah, it claims that it is. So in utils here, when we're writing this, we're using this write, and it claims that it's going to create a file if it does not exist and will entirely replace its content if it does. So theoretically, it should do the thing, right? Now I'm getting the compressed, which is the vec of u8. I wonder... Oh. Write to slice as the entire content. Should I be converting this into a string. So compressed is a vec of U8. Okay, so let's go take a look at write. Maybe that's... No, not standard format write. This is standard FS write. Okay, so it wants... Okay, so it could take bytes, or it could take just a string. Huh, the bytes or the string. What are you right now? You're the bytes. Compressed, okay, so you're the bytes. That's fine then, right? I don't need to do anything like that, right? And then see, you're running... Okay, so if we turn off this debug here, it's only attempting to share this out now. Okay, that's good. This is different now. Oh, is it because I've been changing the files? So if I do a get else tree with this, not a tree object. Well, that's different, right? Like previously it was yelling at me about it. Something weird. Okay, hold on. Do I want to do something like I only write this out? I don't even have a hash to write out if the objects is empty. Okay, so if objects is empty, I just want to see this, right? Yeah, so it's empty the first time it goes through, and then it's not empty the next time. Do I want to not store this to disk? But instead do all the calculations for it? I mean, no, not really. I guess now I'm confused. What's going on with this? So we're in a for loop. We have our objects, and I'm pushing those in. That's everything in the directory. Not including the name of the directory. I need to... No, that is including. I'm creating a new tree object here. Okay. We create the new tree object that pushes in here. We're skipping one. Oh, we're skipping one. When it's dot and there's only dot in there, there will be no objects in here. So we just start with objects. Okay, I think I need to return an object with a string inside of it. Sorry, an option with a string inside of it. Okay, you can all do your thing, but now I need to say if objects is empty, we're going to return a none. Otherwise, we're going to return this. Now you have a none. Okay, so option. So if we get this point of time, you should exist if we got to here. Let's go ahead and unwrap this. Expect it. So, attempting to get checksums. That way we can read that error if it's a problem. Okay, so right tree, checksum. Right, you're now an option. Again, we should be able to expect this. Getting checksum after writing all trees. Okay, let's try this again. Objects is empty. Okay. Oh. I mean, that's fine. Panicked at right tree, line 40. Okay, so checksum expect. Oh, attempting to get checksum. Which I don't see the message there. Interesting. Okay, hold on, let's try it again. Oh, attempting to get checksum. There's our message. Okay, so attempting to get checksum, which means that it was empty. So wait a second, the top. Oh, because if there isn't a checksum to get, I don't want to give it a tree object. Now, does extends work? So let's see, checksum expect. Oh, so I don't want to do this. We want to pass in a none back. You know what? It'll be a lot easier if we just push it in separately, as opposed to I'm going to have to wrap this. With a sum here, you'll be a none. We'll get the checksum. We'll grab you. It's not a return none, it's a break none. I want to return early out of here. I guess we should just do an if let sum. So if let sum equals that. We do this here. Else. None. That's a little bit easier. Okay, so we have some expect this to be nothing. Why? Oh, because of an else. Okay. No errors. Okay, so we're good with that. So now if I run you, get us tree with this hash, not a tree object. Cool. Okay. Now if we cd into, I should probably be here. All right, so I want a file get objects 3b. Ooh. Why is that one shorter? That seems wrong. Also, mine isn't here at all. It didn't save. Well, that's not good. Okay, so $3B should be the name of the folder, the directory, and then 49 should be the start of the file name, and it's not here. Okay, so all right, so this is what got printed out. Okay, so we get our checksum. Wait a second. I'm not printing the right thing, right? I'm printing it down here. No, I'm not. Okay, so I'm returning the hash. Okay, so we're creating the file tree. We save the hash to disk. We return the hash. This should be the top level hash that we get. And then we return okay with the checksum. This goes to main, I think. This does the right tree. We're getting the checksum, and then we're print lining this out. And so that's the checksum that we're getting printed out. Okay, so in right tree, I'm now curious, is the hash that I'm writing the same one that I'm getting back? So let's debug out the hash. Okay, 3B49 F1. Okay, so that's the one I told to write. Okay. So theoretically you wrote, but if I go and take a look at this, so what if we do tree of, I guess, LT of get objects 3B. Then we should see 49, and we don't. Okay, save to disk. Okay, so directory exists. If the directory does not exist, okay, so let's do, nope. Okay, so creating the directory there. Then we write. So then I want to do the same thing here. And we just say writing file to the new path. Oh, I don't think I can do this here, can I? And you don't implement copy. Oh, you do implement copy. Okay. Okay, writing file to get objects 3B F what? Oh no. Oh, what did I do? Okay, so I'm writing it to get objects 3B. That's correct. The hash is 3B49. Okay, hold. What did I do? Okay, so what is the hash? Okay, so the hash is 3B49. You're writing it to 3BF1. That feels weird. Okay, directory name. Okay, so I'm passing it the hash for each of these. The file name should really be, okay, so debug file name. Okay, so file name is 49F1. Okay, so this is correct. 49F1. Okay, so yeah. Okay. Writing file to All right, I think. So this get objects 3B. I lost this 49. Oh, because of this file name. What was I doing? What was I thinking? Okay, hash mismatch. Okay, now it knows that it's zlib compressed data. So 3B49. So here's 49 F1 through 0. Okay, so at least we have, okay, so this one is now what we expect it to be. It's not a tree object. Okay, so now we need to read, okay, so now we need to potentially read this. So can I gzip was it like decompress? We looked at that. That was like not too long ago that we looked at like the ability to gzip to decompress it. What was it? It was like the DC. Okay, so C is standard out. Oh, decompress standard out. Okay, so if I do gzip DC, do I have to give it the file? No, I give it the file here. Okay, so gzip DC get objects 3B49. Not in gzip format. Oh, because I need zlib. Was there a way for it to tell it that it'd be in zlib? This version of gzip is also capable of decompressing files compressed using compress, bzip, lzip. Okay, so I don't need to do that. I think I probably just need to install zlib, don't I? You shared the ability for me, like a... It's also, okay, so it's also possible to decompress using standard shell script plus gzip. If you don't have or want to use OpenSSL or other tools, prepend the gzip magic number and compress method to the actual data from zlib compress. Okay, so I take this. Now, if I try to print this out on its own, okay, then I pipe that into cat, take in standard in, which is going to be this stuff, and then also that prepends whatever I'm trying to. Okay, and then I pass it to gzip. Okay, and then that goes out. So I want to do that. Pipe this to cat, and then this is going to be get objects 3B49. Oh, okay, there we go. So it does have our stuff. Oh, so we get all these things, and then your get gzip invalid compressed data. So I get the stuff out, and then it's okay. So you have your get .sh is at the end here, and then invalid compressed data CRC error. What's that? A format error? Okay, and then there is this okay, so performing commit consists of writing two objects. First, a tree object, which is a snapshot of the current directory. Tree just lists the hashes of the files, blobs some subtrees, and directory it's recursive. So that if any file in the tree changes, the hash of the entire tree changes too. Okay, so okay, so we get the mode path. Okay, plus, okay, so we get the path, the mode, and then the SHA. But was that the end? Okay, you know what I want to do? I want to find other tree objects. So let's do this. I want to get write oh I did not want to do that. I get add. Okay, so if I do a get write tree, that gives me you. So now I want to do a I'm gonna do that same thing we did with our printf, except I want it to go to objects 47 F1. Oh, gross. Okay, so we have gzip certainly isn't happy about this. But okay, we get our tree. We get our size 373, and then we get our 10. Okay, our mode name. Oh, this is the SHA sum. Followed by this again. Oh, but it gets a compressed error here. Okay. Well, then that's not necessarily terrible bad. Oh, wait. Am I supposed to have a null byte? Wait a second. In read a tree object, I feel like... Yeah, it's covered here a little bit better. Oh, I think I did it wrong. Okay, so the format of the tree. At the beginning, we have tree, space, size, null. Null are for losers. I'm sorry, but we're getting good, and we have to use null. Okay, null entries having other references to other trees. Okay, then these. So then we have mode, space, file full. Oh, I did it backwards. I did it based upon the way that it's printed by Git ls tree, but it's really the other way around. Oh no. Okay, so hold on. We can fix this. Undefined gang, yeah. Hello, Benzie. How are you doing today? Okay, so we have our header. Our header is okay, so wait, tree file, create tree file. So tree file, string new. So here's, okay, so tree, size, null. Okay, excellent. Then it's gonna be, we extend with these objects, which are the tree object types. And we use display for this. And so I want mode. Okay, so we start with the mode. File name. That's incorrect. Okay, so I want file name, a null, then the SHA sum, that's it. It's just those. And then it's new line. Because of course it is. Okay. So if I do this, hash mismatch. So not a tree object, doesn't like this. Null space SHA or null SHA. Oh, good point. It's null SHA. Yes. It was mode space name null SHA. Okay, so then this becomes, this is our file. Okay. Then I want to do our git ls tree that. Not a tree object. Okay. I mean, we might be getting closer. It's hard to tell a little bit. Geez. Okay, so I'm gonna do get add. Now that is an A29, so cargo run write tree. That gives me you, which is different. Is it different every time? No. Okay, that's good. Not a tree object. Okay, so if I do cargo run ls tree, I paste you in. Main panicked at ls tree line 7. Oh, I didn't get the... Why are you upset about that? Oh, because I need the option. Okay, so it was... Oh, it was something like -p. Unable to get next byte in mode. Okay, so wait, it was get ls tree name only. That's what it was. Well, still doesn't change it. Still not a tree object. Okay, but other things are going well for that. Great, interesting topic. Git client with Rust. That's something to watch. Yeah, it's been interesting. We're decently far through it. The tree stuff is kicking our butt though. What do we use for compression? We're using when I compress it, I'm using the Flate2 crate, and we're using the zlib encoder that's inside of that. And we're using that because our documentation told us that Git uses zlib behind the scenes. So that's why we're doing that. Okay, so we have that coder. Okay, so I'm writing the content out as bytes, and then I'm finishing it, which gives us back the compressed bytes. So that should be fine. What I'm worried about... okay, so if we do printf, the last time that I ran this, we got cargo run ls tree 6a 52. Oh, 6a 52. Okay, so we have tree 532. I don't think I get to see the null, do I? Oh, look, my cursor skips over it, so I think that is a null right there. Okay, so tree 532, and we get the mode, the name of the file, and then another null, and then the hash. Wait. Snoozing the ads. Okay. Let's see. Is the bytes little endian? Oh, I forget the definition of little endian. Hold on. I used to remember this and do it all the time. Right, we have the little endianness and endianness. It's the order sequence of bytes where the smallest address are sent first. Endianness is primary as the big endian or little endian. For ordering, it's not. I don't remember little endian. I remember being taught it, and I remember like knowing it at one point in time. I just like I'm having trouble recalling it now. Finish that problem, run real get in your data and see what the tree it produces. Yeah, we've tried that. We've tried that a couple times, and I'm having trouble telling the difference between, although we can try that here maybe. So this seems to be, okay, so this is 1. I do have a space at the very end, so I don't know if that's gonna cause it. Okay, so this is 1. Let's go ahead and write this out to desktop mine. And let's do get right tree. And I want to do the same thing, printf, pipe into helix, and this is going to be A9 2E. Oh. So we have our tree, we have our size, we have the null bit, we have the mode, we have the name, and then we have just the compression. So, okay, so I have the compressed bytes here. Let's see. I think it was in utils. Okay, if the objects in get object match, the endianness is not a problem. Okay, so I don't think it's the endianness. It looks to me like I'm supposed to actually just put the compressed bits there. Are you printing G as the hex as numbers instead of actual hex code? I might be. That might be what the problem is. Okay, so now when I save to disk, we get the compressed, and I'm writing out, okay, so we get compressed here. We get the hash of the compressed file. Oh, wait a second. Is the hash include, the hash might not include the tree at the beginning too. That might be another thing. Okay, debug hash that directory name, file name. Okay, so go into get objects, go into the directory name, and then, okay, so then we write, and I'm attempting to tell it to just write the bytes directly, so the compressed bytes directly. But wait a second. This is not the problem. The problem is in here, when I do the display, it's the checksum. But I don't... this checksum is a string. But I need you to be the bytes. Oh, no. Are you printing G the hex as numbers instead of actual hex code represented? I think that might be the problem. Yeah, I think I'm doing... I think that might be the issue. Wait, can I... Is there... I could do the hex thing. The hex trick. So, how's a checksum? Can I do something like... hex... encode... like that? Okay, so let's try our print. We'll grab this first. It's gonna be DE38. No, that was not right. It must be decode. Or maybe it's decode. I guess like must be is probably not the right thing to necessarily say. The result, okay. A Vecchi View 8 doesn't implement standard format display. I don't think that's a good idea, but we'll try it. What can possibly go wrong? This is 6.4 1B. Okay. So there's the bytes as a vector. So I need to print out its okay, what am I printing out here? This is the, yeah, it's the SHA-1 of the referencing blob or tree. So it's things like these, and we know it's 20. Okay, so we know it's supposed to be 20 bits. You convert 20 bytes of the SHA-1 referencing blobs and trees into hex string to visualize. So I don't have it correct here. My checksum, when I'm getting the checksum, okay, I hash the object. Hash the object is flight right true. And then this one, I get the check from right tree object. I get the checksum there. Hash object should be right because it was working. It was working for when we did hash object. I don't. Okay, so it's supposed to be the plane. Okay, so I guess I could print out the objects again, but I don't think that's right. So it's supposed to be the SHA sum. The get right tree looked different to the Stack Overflow. Yeah, it let's see, this is the get right tree. Well, yeah, but this is as printed by Catfile, which is different. So Catfile and the actual written in it are different because of course they are. That's not really helpful there. Now this one is, I wrote, normally all the content has no new lines. Also, I converted 20 bytes, i.e. the SHA-1 of referencing blobs and trees, into hex string to visualize better. So whatever that is not supposed to be hex in hex string. Now when I get okay, so when I hash the object, I compress the file, I create the folder, I save the file, and then I just return the SHA. So theoretically that would be okay. Huh. The get right tree looked different to the Stack Overflow, or maybe I did not see it correctly. So if you go back to your Tmux view, I don't think the output was hex. I think it was UTF-8 type of character. Yeah. So if we take a look, this was mine, right? Nope. That's also not right. That's not right. Okay, this is one from actually Git creating it. So we have just this, which is 20 which is the hash of the compressed bytes, but in 20 bytes that are not nice. Oh yeah, it was UTF-8 type of characters. Yeah. Well, wait a second. Is my... Okay, so when I'm doing the hash, am I getting that wrong? Okay, so when I'm in utils, I'm getting the hash. Okay, what am I doing? Okay, so when I'm ls tree, no, it wouldn't be ls tree, right? Because, well, that worked. Can I do the opposite? Okay, so we get you file names push, file name, print name. Okay, so wait a second. Where am I putting? Okay, so I decompress compressed bytes. So okay, ls tree, we get that. We get our hash. We figure out what the directory name is from that. We get the object file name. We create the path to get it. We open the path. We read the compressed bytes in. We decompress them. We get the header out. We loop through. Okay, so we do a parser step. And then we hand it the bytes. If it matches done, we hand it the file names. Okay, so we first check to see if it's like this. Okay, we first check to see if we can get the first the null. Okay, so we know we're in a header until we get the first null. And then we loop. As soon as we get a space, if we're in mode, then we set our type to file name. And then a file name. We wait until we get a null, and then we're in. We push the file name, and then we do that. Okay.